perpendicular lines. We're going to first start off by talking about vertical and adjacent angles. So vertical angles are angles that are across from each other. And in this picture, I have two pairs of vertical angles. I have 1 and 3 are a pair, and 2 and 4 are a pair. Because 1's across from 3, and 2's across from 4. Okay. Are these angles congruent or supplementary? So what does congruent mean? And supplementary? Not quite. Remember, supplementary means adds to 180. So, if I look at the angles 1 and 3, are those the same angle measure, or are those going to add to 180? They're the same angle measure. My next angle pair is adjacent angles. These are next to each other and make a line, a straight line. Okay, so my adjacent angles in this picture are going to be 1 and 2, because those are next to each other and make a line. 2 and 3, 3 and 4, and 4 and 1. So are adjacent angles congruent or supplementary? Supplementary, because these are making the straight line, and the straight line is 180. Okay, so the next thing we're going to talk about is parallel lines. This question is asking what's the difference between parallel and perpendicular lines. So remember, parallel lines have the same slope and never cross. Okay, and then perpendicular lines have an opposite reciprocal slopes, and they cross at a right angle. So given this figure, which lines are parallel? I need to label my lines first. So I'm going to, this cross line, I'm going to label L, and then this one M, and this one N. So just looking at this picture, which two look parallel? M and N. Okay, and then this other line, L, is called a transversal. That just means it's cutting two parallel lines. Okay, so I have some special pair types. My first is corresponding angles. These are in the same spot on parallel lines. So if I take a look, this 1 is in the top left corner, and this 5 is also in the top left corner of the N line. So 1 and 5 are corresponding, because those are in the same spot. And then 2 is in the top right, 6 is in the top right of the M, so 2 and 6 are corresponding. Then I have 3 in the bottom left, 7 in the bottom left, and then 4 in the bottom right, and 8 in the bottom right. Okay, so these angles are congruent or supplementary? So are 1 and 5 the same angle, or are they going to add together to equal 180? Might help if I look at 2 and 6. Are those ones the same or supplementary? They're the same, so these ones are congruent. Okay, so my next line type is alternate interior angles. These are on opposite sides of the transversal. Inside the parallel lines. So looking at this picture, it's going to be 3 and 6, and 4 and 5. Because those are on opposite sides of the highlighted line, and they're inside my parallel line. So these angles are congruent or supplementary? Congruent. And my next angle type, or angle pair, is same side interior. So this is same side of the transversal. Inside the parallel lines. Okay, so these ones would be 3 and 5, and 4 and 6. So if I put 3 and 5 together, or 4 and 6 together, would it make a straight line, or would they be the same angle? Yeah, these ones are going to be supplementary. Okay, my last angle pair is alternate exterior. These are opposite sides of the transversal. Outside of the parallel lines. So my alternate exteriors are going to be 1 and 8, because those are on opposite sides of my transversal outside of the parallel lines. And then 2 and 7. So if I look at my angle pairs 1 and 8 and 2 and 7, are these congruent or supplementary? Congruent. So then I have my converse theorems. What these are is if I'm looking at lines and I don't know if they're parallel, if I have these angle pairs, I can, if they exist, I can decide that they are parallel. So my corresponding angles converse theorem, I recommend you write really small here, is if two lines and a transversal form corresponding angles, that are congruent, then the lines are parallel. Okay, my next one is alternate interior angles converse theorem. So this is if two lines are cut by a transversal, so that the alternate interior angles are congruent, then the lines are parallel. My next one is the same side interior angles. So if two lines in a transversal form same side interior angles, that are supplementary, then the two lines are parallel. Okay, and my last one is alternate exterior angles, the converse theorem. So if two lines in a transversal form alternate exterior angles, that are congruent, then the two lines are parallel. So basically, if I find any of my angle pairs, the corresponding, the alternate interior, the same side interior, and the alternate exterior, and they are congruent or supplementary like they should be, then it just means that the two lines are parallel. So it's kind of working backwards. Okay, so I have some examples down below. This first one wants me to solve for x. These little triangles on the line mean that they're parallel. What kind of angles are these? So both of these angles are inside my parallel line, so I know it's one of my interiors. And then they're on the same side of the transversal, so this is same side interior. Same side interior, are those congruent or supplementary? You can look back at the front side if you need to. So that means I want to add these together and set it equal to 180. So I want to combine like terms. 72 plus 24 is 180. And then what do I want to do next? So So I get 7x equals 84. Then to get x alone, I do what? Divide by 7. So I get x is 12. Okay, so on number 2, what kind of angles are those? Huh? They're congruent, but what's the special name for them? They're in the same spot on both lines. Corresponding. So because they're congruent, I'm going to set these two equal to each other. And then I want to subtract 5 on both sides. Then to get x alone, I divide both sides by 3. X is 20. Okay, so number 3, what kind of angles are these? They're both inside the parallel lines and on opposite sides of the transversal. Alternate interior. Remember, opposite sides of the transversal means alternate, and then interior means inside the parallel lines. These kinds of angles, are they congruent or supplementary? Congruent. So I set these two equal to each other. I have 3x plus 40 equals 4x. And then my first step is to subtract 3x on both sides. So I have 40 equals x. Do I need to do anything else for this one? No, I'm good. I have my answer. Okay, number 4. What kind of angles are these? They're across from each other. Huh? Not perpendicular. It's something we talked about at the very beginning. Not parallel. Vertical angles. So vertical angles, are they congruent or supplementary? Congruent. So I set these equal. I have x plus 16 equals 4x minus 5. So I want to start off by getting all my x's on the same side. I'm going to subtract x on both sides. I have 16x equals 3x minus 5. And then I want to add 5 on both sides. So I have 21 equals 3x. And divide both sides by 3. X equals 7. On these next ones, it wants to know if there's enough information to decide if the lines are parallel and then say why or why not. So on this first one, can I say that these two are parallel? Yes. What kind of angles are those? They're in the same spot on both lines. Corresponding. So this is the corresponding angles converse. I'm going to make sure you're taking notes. Okay, what about the next one? Can I say that those two lines M and N are parallel? No. Why not? I don't know any of my angles on N. Okay, so remember, I'm trying to decide if M and N are parallel. Do I have enough information on this next one to decide if M and N are parallel? No, again, I don't know anything about N. Okay, and then my last one, can I say those two are parallel? Yes, and these ones are what kind of angles? Not corresponding. They're congruent, but that's not the special name for them. So they're on opposite sides of the transversal, inside the parallel lines. These are alternate interior. Okay. On number 6, it wants me to find my value of x that makes the two lines parallel and then to justify my reason with the converse theorem. So what kind of angles are these? They're on the same spot on both lines? Yeah, so this is my corresponding converse. So then those kinds of angles are congruent. I set them equal. To solve for x, I divide both sides by 2. X equals 66. Okay, so number 7 gives me this diagram and wants me to prove that P and Q are parallel. We're going to do the proof down here. So remember, 2-column proofs have my statements on the left and my reasons on the right. Okay, so number 7 gives me the diagram. R is parallel to S, and 1 is congruent to 3. So that's going to be my first statement. And my first reason is always given. So because R is parallel to S, I know that Q is a transversal from the picture. I'm just going to say this is given because I can see that on the diagram. Then the next thing I'm going to say is angle 1 is congruent to angle 2. What kind of angle pair is that? I'm looking at those two angles right there. Those are corresponding angles. So then I'm going to say angle 2 is congruent to angle 3. If I notice, I had 1 is congruent to 2 and 1 is congruent to 3. So this is taking my transitive property, because I just replaced it. I could have also said substitution here. Okay, and then because I know 2 and 3 are congruent, I can say P is parallel to Q by the alternate interior converse. Okay. So then I just have 2 more on the back. This one gives me that AB is parallel to CD, and angle 1 is congruent to angle 2. It wants me to prove that AD is parallel to BC. So the first statement, AB is parallel to CD, is a given. Then the next thing I have is that angle B is congruent to angle 1. So BC is a transversal, so these are corresponding angles. My next line says angle 1 is congruent to angle 2. How do I know that? That was one of my givens. Then I have angle B is congruent to angle 2. This is just combining those two pieces together. So this is the transitive property. Or I could have said substitution. And then finally, I'm ending with AD is parallel to BC. No, proof is never a reason. So if I look at these two angles, 1 and 2, those two are I'm going to do the corresponding, angles converse, because they're in the same spot. Okay, and then on my last one it says AB is perpendicular to 80. And then DC is perpendicular to 80. There's a typo. It wants me to prove that angle ABC is congruent to BCD. Right. So that means I'm going to want another line up there. So, 1 says that AB is perpendicular to 80. That was given. 2 says DC is perpendicular to 80. That's another given. Then I have AB is parallel to DC. This is the same side interior converse. And then anywhere it says BCH should be BCD. So then it says angle ABC is congruent to BCD. So these are the two angles I'm looking at. Oops, BCD's right there. So these are going to be same side interior. And then I go from congruent to equal, so that's just definition of congruent. And then remember, what steps will help us when we're trying to figure out a proof or what comes next in the proof? You look at the previous step.